to this session. I'm just going to briefly introduce both of them. Jay is one API technical program manager, Bureau by Asia, software products and ecosystem administrator. He holds a master's in IT, certificate in data science and advanced mathematics in and has a vast experience in academic engagements with premier institutions. Sriram, who will be joining us online.
There's a mute all option.
He's a lead technical evangelist of the Pacific Japan Developer Platform and Evangelism at Intel. He has over 15 years of experience in the industry and academia together. Jay and Sriram, over to you.
Yeah, thank you, Professor Rupesh Nasri. Can you all hear me? No, I'm asking those people on the bridge actually.
Yes.
Okay, all the others, can you please mute yourselves? Because there is some feedback and echo coming. And Sriram would continue to admit those who are coming in and maybe look at the total numbers or the peak attendance numbers. Yeah, now I am sharing my slides, the slideshow mode, and I'll be moving the slides. Okay. So thank you, Professor Rupesh. And I see students coming in. All of you welcome. So I have come here before February 2023, and my colleague Sriram also did a similar virtual workshop. Practical part of it, the demos conducted virtually from a different location. Right now he's in Coimbatore. I've come from Bangalore, India. So glad to meet all of you. I don't see any senior students here. Any particular reason? They are probably on the. Okay, good. So I just wanted to do a quick poll. Are you all the undergrad or masters? All of you are masters. So how many of you are from computer science? Okay. And anyone in the third or fourth year? Okay. So those who are not in the final year are eligible, or if you are interested to apply for the student ambassadorship program that Intel has. Last year I talked about the same, and Professor Rupesh introduced me to a few students, and we encourage those students who have good ideas of doing project on one API about which I'll be talking today. You can submit the project ideas to Professor Rupesh, then we forward. We can consider onboarding a few student ambassadors this year as well. Okay. So I'll be taking about an hour plus to talk about one API, generative AI. I know some of you are very much interested, must be interested in generative AI. How many of you have heard of generative AI? All of you, LLMs. Okay, are you all studying that field or just getting started? Sorry? Exploring. Exploring, good. Okay, good. So we'll talk about the generative AI, LLM, and the Intel's way of approaching it, and what are the hardware and software stack that we are preparing to support this emerging field. In fact, it's already emerged in some sense, but there are new use cases coming out in the industry. So we'll talk about some of the possibilities, and then the agenda is going to be like this. I'll give a quick introduction to Gen AI. It's being recorded, isn't it?
I think you are sharing another screen.
Sorry.
So it's in presentation mode, right?
Yeah.
But you're sharing another screen.
Participants are not able to see the agenda slide. It's below.
We are seeing the first page, the title card only.
Yeah.
Oh, how come?
So you're sharing the screen, right?
Just unshare it
choose the
once and
view.
reshare, Jay.
So just unshare.
It's already unshared.
You are not sharing the entire screen.
No, it's only.
So now we
Are you able to see my slide?
Yes, can you move to the next slide? Just to check if things are moving.
Yeah,
now it's
coming.
moving. Now
it's coming.
Okay. Just that I need to manage the time. Okay, we'll leave it at it. I think you all can see this, right? Are you able to see this, the room?
You can go to the slide. And the full presentation was.
So that wasn't working, right?
Okay.
Whatever you want, you can do.
So you're choosing the screen, right, when it's sharing?
So there is a maybe you can open the slides.
Yes. So this is the screen you're sharing,
Yeah.
right? I just
That's what I did.
personally.
So we'll have to share it, I think, after putting it into the presentation.
You want to share the screen or window?
Win.
Window or screen? Screen meaning
Yeah.
it'll be easier sometimes.
Okay, fine. Yeah, it's coming.
Yeah.
So Sriram, you're able to see, right?
Yes,
Sriram? Okay,
yes,
good.
yes.
Okay, sorry about the interruption. So we will cover the generative AI, the theoretical aspects of it. And then how many of you heard of heterogeneity in programming?
Tell me what it is. Combining the CPU and also other accelerators.
Correct.
in program.
Kind of, yes, you're right. So we'll talk about that, what Intel has in terms of product range and what software stack we have built up over the last 4 years to support the heterogeneous programming or what is called cross architecture, cross vendor programming, and the one API toolkits. And then little bit on the LLM and generative AI. I will also give introduction to, in my section, 5 will be moved to 4, which is the Intel Tiber Developer Cloud and the Gen AI aspects of it. Later on, after the break, three of my colleagues would be coming in to conduct some demo, and you can also register if you have not already registered. We'll show you how to register and get access to the cloud, and then you can run the scripts yourself. Right, and then we will also talk about the Hugging Face. How many of you heard of Hugging Face? Tell me what it is.
I personally use it for transformers,
Okay.
training transformers.
Okay, that's correct. So it was an organization or a company formed in 2016 in New York. So since then, there's a lot of development that happened, and Intel partnered with them in 2022, roughly about 2 years ago. And we are developing models and uploading in that field. Therefore, this. And then there is also a quick overview we'll give on OpenVINO, and we'll be happy to take any questions. So, Sriram, we have the HOD, Mr. Krishnan. Krishna. Dr. Krishna is there in the room.
Great.
We'll also get a chance to take a group picture at the end so that we have some memories. Not working. So we'll talk about generative AI. It's a subfield of AI. AI itself is a big circle, right? You will have seen this picture in many places. You have AI, then machine learning, then deep learning, and then there's a section of that would be Gen AI. So it utilizes the deep learning algorithms to generate using something called a prompt mechanism. Realistic and creative text. It's primarily used right now in the NLP domain. Create text, audio, video, pictures, all of that. And then they are trained on massive data sets to learn from underlying data that's been developed all over the place. And it also determines the relationship between the different data sets. And then this enables them to produce novel outputs that are consistent with the training data. I talked about text, audio.
So Jay, can you come out of the presenter's view and go for normal view, Jay?
Presenter's view.
Yeah, we are seeing your presenter's view. Can you come for the
it's
normal view? Yeah.
Hide presenter.
Hide presenter's view and go ahead. Yeah. Perfect. Thank you.
Okay.
Perfect. Thank
Is
you.
it good now? Okay.
Yes.
Thank you. So the impact of generative AI is still happening and it's going to happen. It's going to continue to happen in the coming years. You will see a full flow of the generative AI taking charge of many different domains that we are all used to working. So it optimizes product design. Design is one important aspect. How the products are getting designed and developed, especially in the creative space, how we can do prototyping faster, where we have to spend lots of years, probably will be cut down to 1/5 or even 1/8 the time. And then how these models can create the design is superior performance. And the chances of making errors will be reduced drastically. And then how the AI powered simulation can predict any issues that may happen in future. Right, so generative AI technology will lead us to more and more accurate and faster product development cycles. The future of research with Gen AI. So as I said, it accelerates, and when I said faster, it accelerates the scientific discovery and innovation. It assists researchers in formulating new hypotheses, right? If like this, it's not like this, different combinations of conditions that exist in the data set. So all of them can be juxtaposed between two or many different data sets, and then the outputs can be generated to really give a creative space for how the engineering can happen, the design and development. And then they can generate novel materials using the molecule. It's not just in the computer space, right? It can go across many different domains, molecules, designs for their explorations. So as I said, AI can analyze vast amount of data to identify patterns and relationships. That's very important. It's not just that the backend has to be still the technology that drives it. The technology meaning the software and the hardware, and Intel is building all of the hardware roadmap that's required, and then the software stack on top of it. This can be potentially missed by humans, right? But the computers have much higher possibility of detecting all of that. So I talked about one API. So that is the building block. On top of it, all this is built. Then I also talked about heterogeneous programming. I think this person was rightly identifying. Over the last so many years, across multiple surveys, especially by organizations such as Evans, they found out that more and more programmers want to not just use one device, one platform, but be able to program across multiple architecture, also across multiple vendors. That's called cross architecture programming. Today, or in the recent past, if you were programming a particular device, the programming tools and the languages you had to learn once. And if you have to go to, let's say for a CPU, and then if you have to go to a GPU programming, it had a different set of programming languages and toolkits that you have to get familiarized with, and then FPGA. It wasn't really helping the programmers move workloads across different architectures. You were more or less stuck with the vendor that was locked in, right? So if, let's say if you go to CUDA, you only have one device or one vendor that you can program. Intel introduced about 4 or 5 years ago this concept of one API and SYCL. SYCL is the evolution of the original C++, the C++17, I think. So they continue to evolve over the last many years, and the heterogeneous programming aspects have been added as an extension, where you can take the program and deploy it across multiple architectures. Multiple architectures meaning CPU, multiple architectures meaning CPU, GPU, FPGA, other accelerators I'll talk about. CPUs generally scalar programming. GPUs vectorized programming. Any of you wanted to do parallelized programming, you distribute in terms of vectors. And then FPGA is a spatial programming, and you can have matrix programming. So all of these in the past was very difficult to move across. You master one type of programming, you can't do the other one. You need to relearn and redeploy. So with one API concept, what the industry achieved, right now it's called the Unified Acceleration Foundation, UXL Foundation. It was originally maintained by one API. Now it's since last September, it's called UXL. Google, you'll find that. So there are multiple partners that are working together. We have one standard set of there's open standards that have been built in for the programming paradigm, where you can move from CPU or GPU. The workload can be moved from CPU, GPU, and FPGA, depending on what the needs are. So industry is becoming more and more complex, and you don't want to be tied to one set of programming language. Second thing is also deriving the maximum out of what you have already put in place as infrastructure in your IT equipment, right? Depending on how many GPUs you have, how many CPUs you have, what kind of CPUs you have, or FPGAs, you want to derive the maximum out of it. In the past, if you invested in one, you can't really use the other one, even though it may be lying unused. Now you are able to balance the workload. So it's moving the workload, meaning not only your ability to program across, but also getting the maximum out of the already made investment. And so that's the important change that happened. So multiple architectures, multiple vendors and programming models. So this has been taken care by using one API. It's based on the open standards, multi-architecture programming. So a little bit more on one API. So the bottom layer, you find the CPU, GPU, FPGA, and other accelerators. Like I said, you have the freedom to make your own choice and performance, right? Realize all of the hardware value. Whatever money that you have invested in all of the hardware that you purchased so far, you should be able to make the most out of it. And then productivity. Be able to program quickly instead of having to take the program, run it across different architecture, and then bring it back again. So all this means that there is a less efficiency that's built in. With one API, you get much better productivity. You can develop performance code quickly. So one programming model for all. So if you already have a CUDA program running on a second vendor, right, and then you want to move it to SQL, that is also possible. We have a number of different examples. We have partnered with top universities in the world, both in the US and Europe, where they are taking the already available application of open source like Promax and NAMD and others. They are taking those applications that are right now, or in the past working on CUDA, they ported it to SQL. But once they move to SQL, they have a lot of freedom. So they no longer are tied to one device or one vendor. So they can move it across GPU, and not only tied to Intel also. When we say move it across vendor, we can continue to use the old vendor or Intel or any new vendor that is subscribing to this open standards that is maintained by the Unified Acceleration Foundation, UXL. So you get the freedom to make your best choice, you get the performance and also higher productivity. So having said that, what are the toolkits? So this one that I showed was very high level. I want to go into a little bit more detailed view of what one API toolkits are. Now you have three sets of three layers you can see here. One is the base toolkit is the one building block across all of them. So this has got the core set of performance libraries that support SQL, C++. Some of you must be working on HPC applications here. Anybody? Nobody here. OpenMP. Anybody knows? Those professor will know. So okay. So what type of? So you're studying about that? Yes. Okay. So base toolkit can support all of this: C++, SQL, OpenMP. Right, and then if you're working on, let's say, HPC application, high performance compute applications, then you will be working on Fortran, OpenMP, and API. And then if you are working on visualization projects, rendering projects, so graphic visualization, we have a lot of these centers of excellence established that are working on really mapping Cosmos. In fact, we have one center of excellence in Cambridge, University of Cambridge. They actually take the picture of the Cosmos and render it in situ. They don't store it, they render it in situ on the screen. So they are doing projects using the rendering toolkit. And then, of course, many of you would be knowing about IoT. They are in different domains that they are using. So these are all domain-specific applications, whether it is HPC, rendering, or IoT. Then there are other toolkits that are powered by one API. So that is the AI analytics toolkit about which we'll talk a little bit today because this is an AI session. And then also OpenVINO. So visual inference neural network optimization tool, OpenVINO. This is the OpenCV evolution from the past. Many of you who have computer vision projects certainly want to take a look at OpenVINO. And this is for all the MLDL type of projects, right? Machine learning, deep learning. So you have whole set of libraries and frameworks that are part of this. Little more granular view again. What does one API based toolkit have? This is the most important thing. This is the building block from which you have the other things, that is HPC, rendering, or IoT, or the analytics toolkit or OpenVINO. So this is the base one. So you have the direct programming possibilities. I talked about the C++ compiler, the DP++ compiler. Right now it's called SYCL. And then the compatibility tool. The compatibility tool actually helps you move the program, the application, which was already written in CUDA, to SYCL. So CUDA is you're logged into, let's say, NVIDIA. If you want to, if you can move to SYCL, you can not only program on NVIDIA, but also on AMD, Intel, or any others. Right? So that is the freedom that you can have. Then the Intel distribution of Python, that's very important. It's got the built-in optimized libraries, which will give you the best performance for you. And then the FPGA add-on if you're working on FPGA application. Anybody working on FPGAs here? Okay. Then you have all these other API-based programming tools, whether it's the DP, C++ library, math kernel library. Anybody start up here? MKL. Last really is. Okay, so that's equal to that one MKL. Then the data analytics, if you're doing any data analytics projects, certainly want to take a look at this one DAP as a library to be used. And then the threading building block parallelism, the collective communications library, 1CCL, for really distributing it across multiple nodes, real workloads, on doing multiple nodes. This is the library that you use. And then the deep neural network library, 1DNN, and then performance primitive. Then we also have something called the analysis and debug groups. Let's say you already built the application, how well it is running. You want to know in terms of its performance. Then this is the profiler tool that you use, right? Whether it is performing up to your expectations, what are the changes, what are the red areas in the application, what are the bottlenecks, how can you speed up vectorization, all of that you can find out. This is the advisor tool. Let's say you already have an application running on a CPU. You want to try and run it on a GPU. Now, before you actually move it to GPU, you want to make a projection. So if I move it to GPU, how will it perform? You need to have that view even before you start it. It won't be 100% accurate, but it will give you a sense of how well it will do. And you use this advisor tool to project it. Then you move it to a GPU. And then really understand how the performance was. What was the expectation and what's the actual thing. So these are all the things. You have the direct programming, API-based programming, and the analysis and debug tools.
And
Yes.
this compiler, does it compile to NVIDIA's GPUs or?
SYCL, yes, yes. SYCL, you have an extension. You can have a plugin. For both the AMD and NVIDIA, when we plug in, then you can deploy NVIDIA device.
And the programmers have to specify any specific reports.
That's correct. So you have to specify the device. What is the device? So there are some a few extensions that are provided where you can identify which device you want to deploy it on, whether it's a CPU or a GPU, what it is, and then deploy it. So that's why I mentioned this enables the heterogeneity across architecture program to identify the device and deploy it. So you can run the code like that. So let's dive a little bit more into AI, as I said. So what are the main aspects of the AI pipeline? Any of you working on AI projects right now? Any data science type projects? Maybe that person, can you tell me what are you doing?
Time to work on decision transfer.
What is that?
Decision transfer.
Okay. If you look at this, the most time consuming part would be this, right? Data preparation. Because data is all over the place and you need to really bring the data into certain forms and then train it, right? You have this whole flow, data collection, ingestion, analysis, cleanup. These are all the stages that really take up a lot of time, and then labeling. Labeling also is an important thing, right? And then validation, prepare the data, basically prepare data prep. I will call this as a data prep, data transform, and then training it. You create the features. Any of you who are doing this data science project, you know, the model selection, then the evaluation. So you build models to make sure that it's something like roughly translated into, you go to a, some big, so the better, yes, when you drop the point, you pick the select, let's say Coca-Cola, then what you get. So it's an overall model, right? But the algorithm runs inside that. So you create the models by which you can ingest the data, and then you get the output. Then you have the optimization. After you do that, you verify the performance is good enough or not. Then you do the optimization, packaging, then performance monitoring. And then this is across multiple data pipeline, whether it's database, data warehouse, data lake, all of that is involved in this. These three stages: data, train, and deploy. Here again, you will split it, right? You have training data and then test data, then train, test, validate. So all of that will be part of this. So this is the AI pipeline that runs on Intel architecture. What I'm trying to say here is Intel can support end-to-end, whether it's the software or the hardware space. So a little bit more here. Most of the data prep work, you don't need a GPU, and you will only work on a CPU. You're going to really clean up the data, ingest the data, and then clean up, prepare. So you only need something like a Xeon CPU, right? And that happens even today. You continue to use that. But however, when you go to traditional machine learning, you require a lot of memory, right, in terms of processing the data. And that can still be supported by a CPU with faster cores and huge memory that's available. You want to really do deploy again, CPU will do the job. And we also have something called Gaudi, the new accelerator that you can use for deploying. However, for training, that is the most intensive task, right? In terms of the compute side. Here you have three different options. You have CPUs in some cases, you use and then GPU for most of the other applications. Till about 3-4 years ago, we didn't have a production ready GPUs. Intel was mostly known as a CPU company and some LPUs. But we started designing GPUs about 4 years ago, and we have a lot of CPUs, GPUs that can be plugged into laptop or desktop server anywhere. So we have different grades of GPU for different applications. So we have Intel GPU that can support it, and then Gaudi, like I said, has been recently released the version 3 of that. So you have accelerators that are well suited. Xeons are having built-in AI capabilities to deliver compelling total cost of ownership. So this is the general architecture you use in terms of hardware. For data prep, cleaning up and all that, you use the Xeon. Training, you have a choice depending on what type of applications they are. And then deploying using these devices. Let's build the other thing, right? So, like I said, the stack is built on top of the low-level performance libraries, compilers, and kernels. I gave you a view of the one API based toolkit, the center one. So you have the compiler, then you have all these libraries, collective communication library, one PP, and all of that the bottommost layer. So these are sitting on top of the hardware, just on top of the device. You have all these libraries. Many of them are performance libraries built for Intel devices. They are all freely available, by the way. It's available free. And then The AI libraries, tools and frameworks. This is where most of the AI developers operate. So you pick a particular framework, let's say Python, and then build your program, right? So these are the low level ones. All the libraries I mentioned, vertical stack. If you want, I can give you a few again. This one. These are all the libraries. And that's the low level library, and then the compilers. Then you go to the next layer. AI libraries, tools and frameworks like PyTorch or optimized TensorFlow, all of that. And then you have the MLOps type of productivity application. Anybody heard of MLOps here? Okay, so you've heard of DevOps, right? Machine learning and DevOps, you put them together. How do you deliver machine learning programming architecture to production? Continuous integration, continuous deploy, the CI/CD kind of thing. So you create a machine learning program and also production, how you continuously integrate and deploy. That's an emerging field. I suggest that all of you take a look at it in technical as a developer certification program for MLOps. Just Google, it gets certified. It's just about $300 once. It's highly valued in the industry. Right? So it gives you a better chance to find jobs in marketplace. Okay, so I hope this is clear. When you want to deploy model, the data prep model and deploy. So this is the software stack that will support this. So one view of the top Python libraries, the machine learning space. I think many of you will be aware of NumPy, SciPy, all of that, right? Intel has got its own optimized version that's packaged as part of the Intel distribution of Python. Then you have XGBoost. There are many different libraries you might have used. But one thing that I think many of you will be familiar would be Apache Spark. Any of you used Apache Spark? Can you tell me how it works?
So I had used this again, and it was reading from the that is plus bucket inside the running jobs in that.
Okay, good. So in memory, you're using memory.
Yeah, it is deployed bucket.
Program using SCADA.
Okay.
Okay. Okay, so Apache Spark is one. Then you have the other thing, right? For the deep learning, NLP, computer vision. I think I touched a little bit on this Hugging Face. Somebody was using. Then there are a number of different other Python libraries that are available.
I'm just looking. Device. What's the y-axis?
Oh, this is the stars number of users in. Yeah. It is stars. Yeah, I can see it blurred. Stars. So here you have AutoML data. You can go to this site, ednuggets.com. To simplify our AI developers' lives regardless of how they consume the software. So, generally the Intel participate. Generally, Intel participates in the open source community to develop many of these optimized. We talked about the scikit-learn here graph, right? So we have an entire project team that works with the open source community to develop this. And then we also develop the end-to-end tools and kits to accelerate the time to solution. Meet developers, that's our objective, right? Meet developers wherever they are, whether they are in university or industry. Okay, again, starting from the earlier slide, basically ideally we would like to upstream all of the optimized performant libraries that you saw in the slides before, integrate acceleration into popular open source software. But sometimes it's not always possible. Then we provide extensions to those the open source, and which are easily pluggable extensions to the open source software. Again, some of them that we have worked on is scikit-learn, PyTorch, TensorFlow, etc. The third one is the distro. If this is not possible, again, we are not able to provide an extension or upstream it, then we provide a distro version of that again in the open source domain. The optimized distribution, which has got all the interdependencies taken care. Let's say you have different sets of libraries which have to work together, but it's not always possible within the extension domain. Then we release a total distro again as open source one. If these three are not possible, then we create a totally new set of toolkits. Like I mentioned, OpenVINO is available for download. It's not, it's free, but it's not open source. Like Big DL is one where you bring together big data together. And then Converge.io, the company that actually sometime back acquired. Let's move to the next slide, which really has again a different view of this. Engineering the data, creating models, optimize and deploy. Go back to that slide where we had data modeling and deploy, train and deploy. So that's what it is. What are the different libraries that are used? SciPy, NumPy, NumBar, PySpark. So all of that for engineering the data, preparing the data. Modin is again, you have, you know about the pandas, right? Data plane. So you have a parallel version of that. And Modin is the Intel optimized model. We have that. Then create the model using some of these utilities and libraries, PyTorch, TensorFlow, XGBoost, etc. Then we have something called ONNX, Open Neural Network Exchange. You'll be able to pick any one of those frameworks or use OpenVINO or Intel Neural Compressor. There are different ways to deploy it using different packages here, different frameworks here. And then you can use the Intel Tiber, about which we'll talk again, or use the Hugging Face platform. Intel is like a Hugging Face. Again, they are in the NLP space based on the transformers. So they've been around for a long time, but we are collaborating with the last 2 years. So this is the Tiber Development Cloud. It makes it easy. All of you can get access to that. Create an account, Intel account, register for it. My colleague, or I can show it later on. Access the latest Intel hardware and software. You don't get a dedicated access, but you get what you call Slurm access. Not 3 tiers, so it's standard, premium, etc. Most of the general usages get a standard access. Will be able to use it. And ready to use deployment and development environment. So you'll be able to do a lot of development within that and prototyping and then on the design to deploy wherever you want. But it provides entire environment which you can utilize all of the latest libraries and frameworks and some of the hardware that are available for the access after a certain number of days. Right? And if you really want to deploy it in a professional environment, we also have a premium one where users will pay. The access to host system with the latest Intel processors, complete comprehensive catalog with Intel software toolkits and libraries. It also has got support resources, sample code, and some training material. You can go get some training and then start using it. So you go to here, I think it's cloud.intel.com. Go get a https://cloud.intel.com to get a sign in member, become a account holder. And then it's a standard. I highly suggest you use the institutional email ID so that you can identify who they are. And then be able to get started with Intel, gives you early technology access, and you can deploy at scale, then see how it works. It's a production, the prototyping environment. Later on, you can decide how to go to production. So what are the softwares available? As I mentioned, you have all these base toolkit, rendering toolkit, HPC toolkit, all of them are available. Then you have the frameworks and other tools, right? For example, optimize PyTorch, TensorFlow, scikit-learn, all of that. And you have all these AI foundation models. So again, the hardware is like this, different types of CPUs, and then GPUs. Like I said, we have the Flex series and the Max series, depending on your application. Max is the higher performant one, and then you also have the Gaudi processor, Gaudi accelerator. So all these are available. You can go get access to cloud.intel.com. Get an account. So like I said, you have the standard account, the premium account, and the enterprise account. Let's say you're a company. We also partner with some companies. We want to get continuous access or what we call bare metal access on the cloud. So they sign up for the enterprise access. If you're premium, you get some level of bare metal access. You get early pre-release hardware access. It just be released. Premium customers would be the first ones to get. And if they've been around for some time already, then you go to the standard access, you get free. Right? You can develop your AI skills, access to all the learning resources, and also community support is available. If you have any issue, you can raise a case, somebody will come and respond there. So this is the landing page. When you get into that, it looks like this. So like I said, cloud.intel.com is the place to get it. Right? The documentation, service, you have all the knowledge base. So when you get in, this is what, once you get an access to your account, to log in, this is what you would see, the home page. Right? Any of you got access to the Intel Developer Cloud? Now it's called Tiber Cloud. If not, I would suggest that if you have a laptop, try get access to it. Create an account and see how it works. This is how it will look like. You have the hardware catalog, what are the different types of hardware you have, and my colleague will be able to show you how it looks. And then the different compute instances, file storage, all of that. Then you also have training content, right? Learning and support, how to get started, tutorials, what is new, and then some sample codes. And that is what we'll show in today's demo. Text to image, stable definition, all of that. Today we'll show some of that. The intention of this particular session is not to go into the full breadth and depth, but give you an overview of what all are available so that it will enough leg up to go and learn more in coming months. You can register this as a mobile, you can put it, then go register.
Purpose of one MPA is what I understand, like when I have multiple types of accelerators, like including everyone.
Yeah.
I develop my application in such a way, and I also configure my CI/CD pipeline or deployment facility in same manner. Then when I particularly, I mean, finally host it into real time for, I mean, usage. I mean, when I deploy it, so then the instance that I currently like, so far that generally it certainly has a CPU.
Yeah.
But here we also get those whatever we require.
Yeah. If you want to deploy it on a GPU, you identify the device and then deploy it. And you can run the code on that. So it will identify whichever device you want to run it on, then deploy it. So that's the power of heterogeneity. Okay. Like I mentioned in the beginning. And you can do all of that and put it on the cloud. So it determine what are the different resources that you've already used. Okay. So let's talk a little bit about the Gen AI use case, the cloud. So like I said, this is the original slide I wanted to show. I think many of you would have seen this circle and all this, right? AI, machine learning, AI as a concept has been around for the 1950s, 60s, during machine and all that. So machine learning became a reality sometime in the 80s. A lot of data started flowing through machines and systems where machine itself would be able to start learning from it. Deep learning is a more recent one that's about 15, 10 years. So that wasn't available. That's when all the computer vision, NLP, all of them took off. But the separate branches of study with technology, the new applications started emerging in multiple domains, right? It could be in healthcare, in finance, in transportation, it could be in engineering design, like I said, drug discovery, all of that. Deep learning became a reality about mid to 2010s, 2013, 14 time frame. And then generative AI is more recent. That's some set of deep learning. And then you have diffusion and LLM. I talked about the large language models, data sets available across multiple studios, bring all of them, and create powerful mechanism to prompt and create new sets of text and image. And, we can learn whether it's a cat by training lots of data about the cats. Eventually, you find out that there's a new breed of cat available which you will never be. That's where you have some new possibilities that are emerging. So this is one example, right? There's a company called Midjourney. So in the past, it's a popular. They used to use their software tool creator using thousands of employees. Now this company has been able to disrupt that market by using the generative AI, by using only a dozen or so employees. The powerful technique of generative AI has reduced the time taken to create this kind of photo editing images and drive efficiency in the industry. The increased focus on value of work, leverage technology. So we have to do things faster, more accurate as we want to progress further and further, right? From the time of evolution. See, last 10 to 20 years have been the fastest growth that we are seeing in every industry. That's possible only because of these advances made in the computing field. So there are two models available, discriminative and generative, about which I just talked. It is used to classify or predict whether it's a cat or dog using different data sets, multiple data sets, be able to accurately predict. This is trained on the labeled data. The model learns the relationship between the features of multiple types of cats and then be able to still say it's cat. Human being intuitively we know it's a cat, will bring different types of cat from different parts of the earth, but we still be able to see it's a cat. But for computer, it takes a lot of time to understand because it goes by a set of data. So that intuition has to be built in at some place. Once the model is trained, it can use to predict the label. Now, generating is having generated. Can you generate your own image of a cat, right? By prompting. So that's the most important thing. How deep you want to prompt. Many of you using ChatGPT here. I'm sure many of you, right? ChatGPT is not a lot more than search engine. You can type in anything that you want to know, and the longer or more accurate that you type it, you get the better output. Right? They're asking what is stable diffusion is one thing, and asking a more detailed question of what you want to still be able to change. Right? So generative AI is a subset of AI which can create new content. They're able to create new content from the existing data set. Let's say Virat Kohli fighting with the lion. There's never been such a thing, right? But you can create a program, create an image where Virat Kohli is fighting with the lion. So you'll get an image like that. So the new type of content that you can create. The process of the learning from training enables creation of a statistical model. So when the prompt, your input question is issued, the Gen AI utilizes the statistical model. That would be the expected response, right? And then it generates the content. So here is where the LLM comes into the picture, large language model. So it's a type of artificial intelligence model. You bring in lots of data, generate human-like text. These models are built on TL techniques, particularly using transformers. Somebody said that you're using transformers. So it's more like a recurrent neural network without the recurrence. Use a mathematical definition for that, RNN type of thing. The key feature of large language model is their ability to process large amount of natural language with a high degree of contextuality, coherence, etc. Right? Even if it's a very complex one, it will be able to understand. Like I said, you input more accurate, more detailed prompting or questioning, the response is going to be more in tune with what you expected. Rather than asking a general question. But even today, search engines aren't really able to satisfy all of the different criteria. You try to search for a more detailed one, you won't really understand all the scores and all those things. So you're not going to get through generative AI is possible with the. Is it complex? So as it is trained on massive amounts of data, allowing them to learn the patterns, grammar, semantics, all of that. So it can use a variety of NLP tasks such as text generation. Like I said, it's mostly used around this text generation, language translation, sentiment analysis. So today, elections are going on. Was the latest speech of the Prime Minister taken in the negative sense or the positive sense? Somebody wants to go to the Twitter screens, generate a model out of it. It is possible to do that. And then the political party can get some feedback from the public that's using social media platforms. And then they do the or the Congress manifesto that came out recently, and how well it's been received on social media. So all of that can be done using the sentiment analysis. One of the most well-known examples is the OpenAI's GPT. I think many of you are using companies are using ChatGPT. I think most of you will be in the coming years using the generative AI to create a lot of content, understand, and then create a lot more content. So it's remarkably human-like text across wide range of topics. So here you have base LLM and instruction-tuned LLMs. So base LLM can be considered as a fresh graduate, right, who doesn't have extensive knowledge but still wants to get something out of it. You should be able to get. The instruction-tuned LLMs is more specific. Right, there can be an example. I want to do only that specific thing, right? You can create that kind of. I want to have this kind of cache doing that kind of work, or that kind of it is available in this kind of space. So you can specifically do particular kind of prompting here. So you have a difference between base LLM and instruction with LLM. Like I said, the prompt is like a question or command to a computer, like a chatbot or a text generator. It tells the program what you want. Like I said, popular player fighting with a particular line. We want to create a content out of it. Yes, we can do. If you ask, tell me a joke, that's a prompt, right? But if you want to have a particular type of joke, then you can specify what type of joke. Joke which is not racial or religious. I want only joke about some of things in society. You can specifically tell the system and it will be able to create this. So prompts can vary in complexity and format depending on the task you want to achieve. Then it can be as simple as a single sentence or a complex one, like I just gave an example. What type of joke you want? And the quality and specificity of the prompt can have a significant impact on the quality of the model's response. Then it will come out with something that with the Google search, any of the search engines, it's not possible to create this kind of. Can't say, tell me a joke which does not involve this, which involves this. So it's not possible to get that type of response. But using generative AI, you can create a lot of content. It goes and searches all of the data sets, the LLMs that I talked about. So here is where how the prompt works. It's too small, sorry about it, but this is a very detailed explanation of how. If you want a LLM to generate a description of a cat, your prompt might be, please generate a description of a fluffy orange cat with green eyes. Right? Then it will create a content. In Google search engines, you can't do that. And fluffy orange cat with green eyes. Chances of getting exact of this much lower there. Here it will be much higher because it's looking at all the data sets. It can be tailored for various tasks, whether it's text generation, translation, summarization, all of that. Okay. There are two things, right? Zero shot prompting and then few shot prompting. Right? I'll let my colleague actually take over from here. Sriram, are you there on the bridge? Sriram?
Yes, Jay, I'm there.
Yeah, you can take over from here, right?
Yeah, sure.
Yeah.
I will.
Yeah, it's about 10:30. What we are thinking is we'll take a break for about 10 minutes for
Perfect.
tea. And then you come back and continue with this.
Sure, Jay.
Just hold
Perfect.
on, we need to count down. Thanks. Come back. We'll have a practical demo session. After you have tea, see how to get access to IDC timer. Go through that. We'll explain that, and then show you some demos. Yeah. For 10 minutes. Just 10 minutes, sir. Please come back after. Yeah, you can.
Just let you.
Yeah, sure.
Stop.
Pause. The pause option.
There is no pause.
That's what, for 10 minutes.
Yeah, I just stopped.